solve problems using the normal distribution, there are certain steps we must follow. And they go with the four-step process from earlier in the year, the state, plan, do, conclude. But here's what it looks like specifically for problems that use the normal distribution. For state, express the problem in terms of a variable. For plan, this is where you're going to draw a picture of the normal curve. Remember, you must have this in order to get credit. The do is where I'm going to calculate my z-score and find the area. And conclude, I'm going to conclude in context. Okay, these are the four steps: state, plan, do, conclude. Okay, so what does that look like when we actually are doing a problem? So let's look at this example. And in the 2008 Wimbledon tennis tournament, Rafael Nadal averaged 115 miles per hour on his first serves. So let's assume that the distribution of his first serve speeds is normal with a mean of 115 miles per hour and a standard deviation of 6 miles per hour. Okay, the question is, about what proportion of his first serves would you expect to exceed 120 miles per hour? Use the four-step process. So the first thing we need to do is state. And to state, we are going to say, let's let x, a variable, equal the speed of Nadal's first serves in miles per hour. I want to know, okay, what proportion of that is greater than 120. So I want to know what proportion of x is greater than 120. Okay, I know that this is normal with a mean of 115 and a standard deviation of 6, and so I want to make sure I mention that somewhere. So this is my state. Then to do the do, I'm going to draw a picture. Okay, his mean is 115, so that would be right there in the middle. I want to know, there's 120. This is what I'm looking for, the shaded in area right there. So then I'm going to find the z-score. Z is equal to my value, which is 120, minus 115, divided by 6. And I get a z-score of 0.83. So from here, to actually find the area, there are a couple things I can do. One, I can use table A. Two, I can use the calculator using the z-score and the standard normal distribution. But I can also use the calculator and use normal CDF and not have to use the standard normal distribution. If I go to my distributions and I go to normal CDF, I can actually change the mean and the standard deviation to fit mine as well. So I can use the z-score and get an answer, or I can use my lower bound is 120, my higher bound, my upper bound would be infinity. Okay, but if I'm going to use my actual numbers, I have to remember to change my values of my mean and my standard deviation. Then when I hit OK, it gives me 0.2023, about the same number that you would get if you use table A or the z-scores on the calculator. So to conclude, we would say about or approximately 20% of Nadal's first serves exceed 120 miles per hour. Okay, that's how to do it in all four steps: state, plan, do, conclude. Okay, so let's look at the next problem. What percent of his first serves are between 100 and 110? Okay, so I've already defined it, and since we're dealing with the same variable, we can let this still be our state. Okay, that's what I would write for state. So then I just need to say what proportion are between 100 and 110. So I draw my picture. So if this is 115 right here, 110 would be about right there, 100 would be about right here. I can label them so I remember what they are, and I'm going to color in between them. Okay, if I were to do this on table A, I would transform them both to z-scores, which I need to do anyway just to show that I know what I'm doing. So 110 minus 115 over 6 gives me a z-score of negative 0.83. Okay, side note. Note that this one I was 5 units above and this one I'm 5 units below. Notice how they are the same, but one's a negative, one's a positive. That's because your normal distribution is symmetric. So then when I do the other one, 100 minus 115 over 6, I get a z-score of negative 2.5. Okay, if I'm going to use table A, I'm going to find the area for this one, and then I'm going to find the area for this one, and I'm going to subtract the two. That gives me the space in between them. But on the calculator, I can go to Menu, Statistics, Distribution, Normal CDF, and I can tell it my lower bound is going to be 100. My upper bound is going to be 110. My mean is 115. And my standard deviation is 6. And I get 0.1961. So that's my area. 0.1961 is my area. That's my proportion. And this time I'm going to say about 20% of, because I'm going to round, Nadal serves are between 100 and 110 miles per hour. Okay, we've kind of run out of room, so let's move this down some. And now it's asking for a couple of different questions that take a couple of different things. One wants to know the fastest 20% of Nadal's first serves go at least one speed. Well, we hopefully already know this from the answers we just did earlier from the very first one, but let's talk about how we would do this. I would say, what is the value with 80% of the distribution to its left? Because if I'm looking for the fastest 20, that's this. It's easier for me to look up things that are going this way. So if this is 0.2, then all of this would be 0.8. So with 80% to its left. Okay, so I've stated, drawn my picture. Okay, I have to do this a little bit. This was one of the backwards problems. I'm starting with an area and going back to a value. So there's a couple different things I can do here. One, I can still use table A, but I have to look and find 0.8 in the middle and then look at the z-score. I can use inverse norm on the calculator and find the z-score with inverse norm, or I can plug in the values straight into the inverse norm. So menu, statistics, that's not it. Menu, statistics, distributions, inverse norm is number 3. Okay, I know my area is 0.8. And if I just leave 0 and 1, it's going to give me the z-score, and I can find it myself. And in fact, I need to show my work to find it myself. So let's just leave that right there and hit OK. And you see that I get a z-score of 0.84. So I'm going to plug that into the z-score formula. 0.84 is my z-score, equals whatever my x is, minus my mean, divided by my standard deviation. And when I multiply by 6 and add 115, I get 120.05, which matches up with my answer from the very first one. So, okay, I would conclude and say that the fastest 20% of his serves go at least 120 miles per hour. Okay. Note on the calculator, if I do inverse norm, even though I have to show that work, if I do inverse norm, and I say 0.8, I can change the mean to 115, and I can change the standard deviation to 6, and it'll go ahead and give me the 120.05. So, either way, but you need to show this to get credit. Okay, so the next question is, what is the IQR for the distribution of his first serves? We know that the IQR goes between the 25th percentile and the 75th percentile. So I know that this area right here, 0.25, and this area right here, 0.75. So I use the calculator. I use inverse norm on the calculator to find their z-scores, or I use table A to find their z-scores, and I get a z-score of negative 0.67 and a z-score of positive 0.67. And if you say, well, how can that be? Remember that because this is symmetric, my mean is going to be the 50th. So this is 0.25 this way, and that's 0.25 that way, so they are going to have the same z-score. One's negative, one's positive. So there are my z-scores. X minus 115 over 6. Same thing for this one. Okay, I solve these two. And when I solve this one, I get 110.9. And when I solve this one, I get 119.047. Remember that this one is Q3 and this one is Q1 because this goes with the 25. This goes with the 75. So then to find the IQR, I just subtract. Q3 minus Q1, and I get 8.147. And then to conclude, I say the IQR for the distribution of Nadal's first serve speeds is 8.147 miles per hour. Okay, the question is, what work do I need to show when I do this to get full credit? You need to show the picture and the z-score. You got to find the z-score formula. So you've got to show the picture and the z-score formula or you are not getting full credit. So if I look at this, okay, these next ones are very similar to those we just did. Go ahead and try and see if you can do these on your own. You can actually go ahead and do the whole for next page, the check your understanding ones too, because these are just like the ones we just did, and then I will give you the answers. Okay, the answer for this one, hopefully you got 0.0846, and hopefully you did all 4 steps. So we would say 0.08, or about 8% of 3-year-old females are taller than 100 centimeters. Okay. For this one, hopefully you got 0.4194, and we would say about 42% of 3-year-old females are between 90 and 95 centimeters. Hopefully for C, you got 97.87 centimeters. So we would say that 80% of 3-year-old females are at least 97.87 centimeters tall. And then if we find the mean, this mean and this third quartile, it wants to know what the standard deviation is. Okay, so this one is a little bit different. Okay, if I know my mean is 102 and my third quartile, so if I think about what my third quartile means, remember it means that this much right here is 0.75. So if I go look at my table A or my inverse norm, I would find that the z-score that goes with this, or I might remember it from one we did earlier, 0.67. So the z-score is 0.67. I know that my third quartile, my value that I use the boundary here, is 105.5. That's my data point. Means 102. I need to solve for the standard deviation. So I'm going to multiply by the standard deviation and then divide by 0.67. And I'm going to get a standard deviation of 5.19. Check your understanding. Number 1. Z is equal to 2.33, and the area is 0.0099. Number 2, Z is equal to 1, and the area you should have gotten was 0.1488. And number 3, it should be about 310.72 yards. Okay, these calculations and finding these areas is very important for you to know how to do. So if you have any questions at all, make sure you jot those questions down and ask them during class.